I guess number one.
One. No, but there was there. Here. Okay, so number one. Unpopular today. So you could do this one of two ways. One algebraically, the other in the calculator. So you're given some equation, given a list of domain values, and you have to find the range. So algebraically, you could put each of these values in for x and find y. In your calculator, you could put this in your y equals, go to your table and find those values. I'm gonna do the algebraic way. So I would set each of these up. And then we would figure out what each one is. So this would become -6 plus 4, which is -2. -4 plus 4 is 0. 0 plus 4 is 4. And 6 plus 4 is 10. So then you would list all of those least to greatest in curly brackets. Questions on that one? Or other questions on this in general? Bless you. So if you didn't take out your notes from a couple classes ago, go ahead and take those out. If you haven't gotten a calculator, go ahead and grab one of those.
So can I try to show you okay, that's crazy. That was very far. Oh, thank you.
Yes,
I
it's-
appreciate that.
You're-
I'm right. No, yes. I had a.
I can make extras. I don't have extras. Yes.
Is there a possibility of them?
And then for our range, we're looking lowest to highest. What's your lowest point of this? It is 4. I'm gonna draw in this line. You don't have to do this, but if you want to, you can. To show you where the lowest point is. And then I'm gonna write our range two ways. You can write them both ways so that you remember, or just one. So this is above 4. So it's gonna be everything greater than or equal to 4. Or it starts at 4 and it's closed and it goes to infinity. Remember that you guys won't be tested on domain and range in this unit, but it is good practice for when you're tested next unit.
Oh.
Oh. Domain and range, not graphing in this, but. Questions on that? Yes.
So maybe we just put it, we always put in regular, parentheses, should we never put in like the bracket?
No, it'll always be from negative infinity to positive infinity, so those will always have parentheses. Other questions on to? On the next page, we're gonna do 6 on the graph. So go ahead and put this in y equals. Negative x squared -4. And then we're gonna graph this once you have it in there. On the graph, you just have to know what you're looking for. So I know that the axis of symmetry is gonna cut this directly in half. And it looks like that axis of symmetry is on our y axis. So that means our vertex is gonna be at this point here, 0, -4. So we can put that point in the middle. Our axis of symmetry would be 0. Domain stays the same. Then you can fill out your x's, and I'm going to show you how to find your y's in the graph. Now, when you look at the graph, if you can easily see the points, then you don't have to do what I'm about to do. So like, I'm pretty sure this is at 1, -5. But I could be a little off. It could be a decimal and I can't really see it. And -1, -5. But I just want to make sure those are the points. So I'm going to go into second trace. But this time I'm going to do value. I'm looking for a y value. So number 1. And I would put in one of those values. So when x is 1, y is -5. And that shows me that. So then I know this is -5 and this is -5. And I can do the same thing for -2 or 2, doesn't matter. So second trace, the first one. And then you can put in 2 or -2, doesn't matter. And it'll tell you what the value is. Should have been 8. Then you can graph all those points. So it looks something like that. And then for our range, we're looking lowest to highest. What's your lowest point? -infinity, yep. Highest point? -4. You can write it like that. Or since it's the highest is -4 and everything is below that, it would be y is less than or equal to -4. So either or. Look at the remaining questions on this page and the next. See if there's any you want to see or go over in the calculator, on the graph or the table.
Is the line between the y?
It's literally a straight line. It means such that, so I would read this. Y, or the range is y such that y is less than or equal to -4. Is how you would read that in math terms, but. Yes. Okay, so go ahead and type 7 into your y equals. And once you have that in, go into your table, second graph. we need to find the point in the middle. So find your y values that repeat and find the point that no longer repeat in the middle. What would that be? -2, -8, so that would be your point in the middle on your table. Then you can either look at your table, fill out the rest, or do this part by hand and then the y's. So -4 is 0, -3 is -6. And then it repeats. So we know our vertex was the point in the middle. -2, -8. Axis of symmetry is going to be the x value, -2. Domain has not changed. And then we can graph those points. And then our range, what's the lowest point? -8. And then it's everything above -8, so greater than or equal to. Or it starts at -8. And goes to infinity. Once you have all that written down, find the page that says analyzing quadratic graphs. So this is like review on all the stuff we've been talking about, graphing quadratic wise, put into one page. So we're gonna go through and then we're gonna switch gears. So remember that your axis of symmetry is the line that cuts it in half. So it looks like here is where it cuts it in half. For graph A. And then we would write that x equals whatever that value is. So x equals -2. What would your axis of symmetry be for graph B? 3. So x equals 3. Then remember that your vertex falls on your axis of symmetry, either the lowest or highest point. So what would the vertex of graph A be?
-2. -2, -5.
We'll come back to the maximum or minimum. And then the vertex of graph B.
Uh, 3, 4.
And then remember that the maximum is your highest point, minimum is your lowest point. Is graph A have a maximum or a minimum?
Yeah. No,
Minimum.
what?
It's the lowest point, or
Oh,
minimum. So then graph B has. Domain and range, the domain's gonna be the same for both, so we can go ahead and write what those are.
The domain always be
For quadratics, yes. When you get to algebra 2 and you learn all the different function families, that will change.
oh.
Then we can look at our range. lowest and highest points of graph A.
Graph A would, the lowest point would be -5,
Mhm,
and it would just go up to positive infinity.
mhm. You read either way. And then lowest and highest points of graph B. So what's the lowest point? Is either of those the lowest one?
Would it be negative infinity?
That's your lowest, then 4 is your highest. Great, then the last two questions ask you to identify the equation. Before we figure out which one it is, we can eliminate some of them. Or at least. If graph A faces up, is your A value positive or negative? Positive. So we can get rid of the negative ones. If graph B faces down, is your A value going to be positive or negative?
It's gonna be negative. Not,
Get
yeah,
rid of the positive one. So then you have choices of how to find which one is the correct one. Do the axis of symmetry, graph it. Graphing it would probably be the easiest. Either you were gonna ask something. Did you make a password? So if I were to graph this first one. X squared minus 4x minus 1. And I compare this graph to the one that's given. Mine was graphed to the right. This one is graphed to the left, so it can't be that one. It has to be the other. And then you can do the same thing for 8. So if I put C in. And graph that. This one is graphed to the left. But our graph is to the right, so it's not that one, it's the other one. So we're going to switch gears. So now we've talked all about how to graph when it's in standard form. We're gonna talk very briefly about how to do that in vertex form. This really should have been attached to the notes, but then it wasn't.
this easier.
I feel like it's easy if you know what you're looking for. But a lot of this stuff I find easy, so take that with a grain of salt.
I already see you distributing one. I don't know how I feel about
No.
that.
No,
It's not distributing?
you could to put it back in standard form, but that's not our goal. Okay, so if you're given something that looks like this is your vertex form. Still y equals, you'll have some number outside your a, that's still the same. But now this part has changed. Now we have parentheses, some x minus 8. Inside on the outside square plus a. we're gonna be looking at H and K to help us find our vertex. H and K are like our X and Y values, but we can't put another X and Y since we already have those, so we change the variables. When you go to find your vertex, whatever your K value is on the outside is gonna be exactly what it is. So if it says for number 1 +3, that's gonna be our Y value. But on the inside, whatever it says, you do the opposite. So I call that like the rebel child. It does the opposite of what you tell it to do. You're gonna do the opposite of what it says. So if it says -2, this would really be +2. Oh, that's scary. So then our vertex would be +2, +3. So take what's on the inside, change it. If it says minus, it's really positive. If it says plus, it's really negative. It does the opposite of what you think it's supposed to do. Whatever's on the outside stays the same. And then you could fill out the rest of this information from your vertex. Our goal is really just to show you how to find the vertex. If we want to do a whole problem, we'll do that afterwards. What questions do we have right now? So for number 2, what would your vertex be?
-3.
-3. -1. So if you know how to find it, it's really easy. If you don't remember how to find it, that's when it becomes difficult. You could graph this and you would get the same vertex. What would the vertex of 3 be?
+2, +1. Is that it?
So the rest is the same as what we did before, all the graphing stuff. Are there any of these examples we want to see graphed and all those stuff done? Okay. What method, graph or table? Okay. So we have our vertex. We have our axis of symmetry. We know our domain. Those are all the same. Vertex still goes in the middle. You can fill out your X values. And then to find your Y values, put this equation into your calculator. Make sure you're using the parentheses, putting the square on the outside. And then if we go in the table, we already know our vertex is at -3, 1. So just fill out the rest of those, 7, 1. 1, 7.
I always forget how to get into the table. How do you?
Second graph.
Thank you very much.
Then you can fill out your values. Or plot your values, is exactly what I meant. So something like that.
For the people, like, we go to, like, I was thinking that those, like, when, like,
So I knew to look for these X values. So when X is -5, I'm looking for those X values. Right. And then range, what's your lowest and highest?
Lowest would be -1. Our highest would be positive infinity.
The be everything greater than or equal to -1, either one. Okay, so all that other stuff is the exact same as what we were doing before, it's just, you don't have to do the work. Because you're given the vertex. Could you still put this in the calculator and find the vertex from your table or your graph? Sure. But you don't have to do that if you're given it. Any other questions about vertex form? So that is all of, for the rest of the second lesson. We're gonna start the third, but not finish it today. And then after we do like the problems, we'll be done for today. All right, so just to briefly recap, the first lesson was solving quadratics from square root. Second lesson, how we graph quadratics. The third is how we find solutions on a graph. So I want you to write down this definition first. And draw in these three graphs, doesn't have to be perfect. So roots is really the name of our solutions for quadratics, but we also know them as zeros, x-intercept solutions. We've talked about that before. With our quadratics, there are three types of solutions you may get. Kind of like when we were solving it by the square roots, we could get two solutions, one solution, or none. Same thing. Two would be, does it cross the x-axis twice? One, does it touch it only at one place? None, it does not touch the x-axis at all. So what we're about to do is going to be more than what you'll need to do when we quiz and test, because it'll be graphed for you already. This is just to practice graphing a little bit more. So we're going to do three problems, one on algebraically, one on the table, and one in the graph. And then be done with it. So starting with number one. To do this algebraically, we're going to do the same method we have been using. Find our axis of symmetry.
What is it, -2 divided by 2a?
You're close. Negative b divided by b. Yeah. So this would be -4 over 1. -4 over 2, so -2. And then we're going to find our y value, same as before, put -2 in for all your x's. Be careful with your parentheses and negatives. You can either put that all in your calculator all at once, do it in pieces, however you choose to do it. I'm going to do it in pieces, but if you do it on the calculator, that's fine. So this should give you -4 minus 5 is -9. So that would be our point in the middle. The table is bigger, but it still goes directly in the middle. You can fill out your X values backwards and forwards. If you do the first part algebraically, you don't have to do the table part algebraically. You could, if you want to, it would be time consuming, so I would not advise doing it. I'm gonna put this into the calculator so I can just look at my table and fill it out. So for -5, we have 0, -5, -8. And then it would repeat. So you would plot all of those points. So it would look something like that. So then I have two questions for you. First, how many solutions do we have?
The solution,
2. It crosses, the parabola crosses the x-axis twice. And what are they?
0, -5, and 1, 0.
So this one's a y-intercept. The 1, 0 is 1. What's the other one?
-5, 0. There we go.
So then you can write them one of two ways, as ordered pairs. Or how we were writing our solutions when we were solving quadratics by square roots.
I think I'm good with this a little bit.
So it doesn't matter unless it says specifically write it in set notation, then you would have to do it the second way, or write it by order pairs the first way. Writing it the second way is good practice for when we get to our last lesson. Just keep that in mind. What questions do we have so far on how we find solutions? The next one we're gonna do strictly in the table. So go ahead and put that in your y equals. And go to your table. Find the point in the middle.
One, 0.
0, 1.
No, 0, 1.
So that would be our point directly in the middle. You can use your table to fill out the rest of your values. Sorry, that wasn't the middle. So, oh, I was like, that's also not my problem. Okay, now that should be right. Oh, let me move on. Okay. 2. There we go, those numbers look better. 1, 0 is now. and then you can fill out the rest. So 0, 1, -4, -1, 4, and -2, 9. Plot all your points. It should look something like that. How many solutions do we have?
One.
And then what is it?
It could be 1, 0, correct.
And then the last one, we're gonna do on the graph. So put that into y equals. I don't know what this is. -x² plus 2x. And graph it. Before we fill out the table and actually graph it, how many solutions do we have? Or what is our solution?
No solution.
No solution. None. So you put no solution, none, NA does not exist, any of those, you cannot put 0, because that would mean I have a solution and it's at 0. Then from the graph, I see that I have a point on my y-axis, 0, -3, but that's not my vertex. The point 1/, should be, and that looks like it's at 1, -2, but I just want to make sure, so I'm going to use my second trace and find my value when x is at 1. And that is the case, 1, -2. So that would be the point I put in the middle. I could start filling out my x values. I know 0 is at -3. So that tells me what 2 is going to be at also. I just have to figure out the other two. So we could do the same thing. Second trace, the value when x is -1. -6. And then we just have to find the last one. So you can put a -2 or +4, does not matter. -11. Could be that one. So for the -11 ones, for this graph, we could put it on the graph, it's just one outside, but if you get points like that in the future where you have like a 10 by 10, but you have to graph 15, just don't graph that point. What questions do we have on how we find solutions from a graph? So next class, if there's any we want to see on numbers 4, 5, and 6, we'll start with that. And then we'll move on to this page. So this page is gonna help you do the other two Khan Academies that are up, the zero product property and zeros of polynomials in factor form. So if you want to wait till next class, it'll make more sense. The graph quadratics and vertex form, you should be able to do that one though. If you want to practice, you can practice more in the notes that we were working on, that single sheet I handed you in these notes. Let's start on this page, which is like the last few pages. You can work on Khan Academy from last week, from this week. If you need to finish your tests, you can come see me and work on that. Use this time wisely. Let me know if you have questions.